This is topic 14-1, multiplying polynomials. Our objective for today is I can multiply polynomials. So my essential question will be, how can I multiply polynomials? Prior to this topic, we have been multiplying monomials, meaning one term times another term. Now we're going to multiply polynomials. So how can I do that? Our bell work problem is a review. Each of the following tables contains elements of an XY relationship. Which table contains 4 points that cannot lie on the graph of a function of x? So the question is, it cannot lie on a function. So here's the deal. We know that a function, when we're looking at tables, is that all your x values must be different. Or we say x values do not repeat. Or all x values are different. So we're going to look to see, do we have any x values that are the same? A, we have a 0, 2, 3, 4. They're all different. This is a function. So all those points can lie on the function. B, we have 1, 2, 3, and then we have another 2. So we have a case here where the two x values repeat. This is not a function. That means these points do not lie on the graph of a function. Let's check C and D just to be sure. -1, -2, 3, and 4, they're all different. D, 0, 1, 5, and 6, all the x's are different. So my answer is B. That does represent 4 points that do not lie on a graph of a function. So let's talk about how we're going to multiply polynomials. You will notice in our first example, we have a monomial, which is one term. That's the 3x. And it is being multiplied by a polynomial. Polynomial has more terms, or many terms, poly meaning more, and we have some addition or subtraction going on in between them. So when we multiply these, we're going to distribute. We take the term that's on the outside, in this case the 3x, and we're going to distribute it to each term on the inside. So our step is to distribute the term on the outside, and this is outside the parentheses, to each term on the inside of the parentheses. That means every term. When I say distribute, distribute means multiply. So one way that I can show this is I'm taking that 3x and I'm going to multiply it times each term on the inside. So we'll do 3x times x squared. Then we'll do a 3x times, and then this term is a negative x. And then last we have 3x times a positive 2. So once I have distributed, then we have to use our rules about multiplication with exponents in order to simplify. So I'm going to say, use the rules of exponents to simplify. So what I mean by that is our first one, we have 3 times x times x times x. That's going to give us 3 and then x cubed. From our second term we multiplied, we have a 3. There's a -1. If there's not a negative shown, if there's not a number shown in front of the variable, we know it's a 1, but this time it's a -1. So it's 3 times -1, and then x times x. So this becomes a -3x squared. And then last, again, just rewriting 3 times 2, and then the x, so this is 6x. Now, Our answer, we have to put some addition or subtraction in between them because that's what we started off with. So this negative acts as our subtraction, and since 6x is positive, we're going to put a plus to make it a plus 6. So our answer looks like 3x cubed minus 3x squared plus 6x. And we have now simplified that expression by multiplying the monomial times the polynomial. So example 2 is the same type of thing. We have one term, the monomial, being multiplied to the polynomial. So we're going to do the same that we did before. Let's distribute. So I'll get a negative 2x times x squared. Then we're going to distribute to the second one, a negative 2x times, this is now a negative 4x, because you take the sign with it. And we will distribute to our last term, negative 2x times, this time it's a positive 6. Use what we know about multiplying. We have negative 2x times x times x. This will give us a negative 2x to the third. We have our second term. We have a negative 2 times a negative 4 and an x times x. So negative 2 times negative 4 is a positive 8. So we're going to put a plus. And then x times x gives us x squared. Our last one, we have negative 2 times 6 and then times x. So the negative 2 times 6, that gives us a negative 12 and then an x that follows. So our final answer is negative 2x cubed plus 8x squared minus 12x. Most important part for these is for us to remember to take the sign with the variable and its coefficient when we're distributing. So let's look at problem 3. You notice that 3 and 4 are slightly different than the ones that we had with 1 and 2. The way that they're different, we now are dealing with 2 monomials times a polynomial, meaning we're going to have to distribute twice. I have this first set that I have to distribute, and then I have a second set that I have to distribute. We're still going to do the same first two steps. So the first step was distribute, and I'm not going to write it all out again, but we're going to distribute both. So let's start with the first one. We'll take the 3 and distribute inside the 7x minus 5. When we distribute to the first one, we get 3 times a positive 7x. And then we have a positive 3 times, notice this is a negative 5. Our second thing to distribute is this negative 2 out front. It is going to go into the x squared minus 3. So again, notice how we are taking the sign with the number. So negative 2 times x squared. And then we have a negative 2 times, and we have again a negative 3. So we have to put a negative 3 in the parentheses. Now let's use our rules of multiplying with exponents. Same thing as the first one, use the rules. So we have 3 times 7. This is already written with the numbers first. That's 21x. Then we have 3 times a negative 5. That's going to give us a negative 15. Then I have a negative 2 times x squared. That's a negative 2x squared. And last we have a negative 2 times a negative 3. That is a positive 6. We now get to add one more step, because now we can look to see, can we combine like terms? Because we distribute it twice, that means there might be some like terms. So we are going to combine like terms. Like terms means I'm going to look to see, do I have any other x's that can go with this 21? Has to have the same variable and the same exponent. There are no more x's, so cannot combine anything with it. Next, I'll see, do I have any constants? That has no variables. It's a negative 15 and a positive 6. Sure enough, those two can combine. So I'm going to just do negative 15 plus 6. That gives us a negative 9. Last, I'll look to see anything that can combine with the negative 2x squared. There are no other x squared, so it is going to stay the same. So when we combine these two, we got a negative 9. Our answer, now we can write our answer. Generally, we write our answer with the highest exponent first. So that means I'm going to start off with the negative 2x squared because it's here. Followed by, it's a positive 21x. So it's a plus 21. And then when we combined our like terms, we came up with a negative 9, so it becomes a minus 9. If you write your answer as 21x minus 9 minus 2x squared, mathematically, that is correct. You just need to make sure you could recognize that the answer you have here is equivalent to the one where we put the x squared first. So if I look, I can see my x squared is negative, x squared is negative. 21x is positive, 21x is positive, minus 9 or minus 9. That is why they are equivalent. Number 4 is very similar to 3. We still have two things that we're dealing with. We have our first monomial being multiplied by polynomial, and then we have our second one. The second one is quite interesting because there's not a number in front of that parenthesis. However, we know anytime there's not a number there, there is an understood 1. So I'm going to go ahead and put a 1 there. I'll write it on the other side also. Now we're going to do just like we did before. Let's take our first one. We're going to distribute to everything on the inside. So this is 3 times x squared. Distribute. This is going to be 3 times. This time we have a negative 2x. And distribute our last one. This is going to be 3 times a positive 1. We've taken care of our first set. Now let's look at our second one. We have a negative 1 out front. We're going to distribute. So negative 1 times x. And then negative 1 times a negative 7. Because again, it's a negative that is with our 7. Let's multiply. We have 3x squared. 3 times a negative 2, that's a negative 6x. 3 times 1 is 3, so that's a positive 3. Let's look at our second set. We have a negative 1 times x, that'll be a negative 1x. And a negative 1 times a negative 7 is a positive 7, so we put a plus 7. Now we're going to combine like terms. I'm going to show another way of combining like terms because the first way I highlight it. Now I'm going to show how I can stack them in order to combine like terms. That means I'm going to start with my squared term, and we have 3x squared. There are no other squared terms, so that one's taken care of. I'm going to box in my x's. So I have a negative 6x. And then the other one I'm going to put right underneath it and stack it, negative 1x. Last, I will underline my constants. So we have a plus 3 and then a plus 7. So every time I come to a different type of term, they don't have the same last name, I make a new column. Now when I combine, I see there's nothing being added to the 3x squared, so it stays 3x squared. When I combine the negative 6x and the negative 1x, they have the same last name of x. I can combine their first name. So negative 6 minus 1 gives us a negative 7 and x. And then last but not least, positive 3 plus a positive 7 gives us a positive 10. So your choice, if you have highlighters, you can do like I did in number 3. If you don't have highlighters, you can do the circle, box, and underline, or you can stack them up. You are not required to do all 3 methods. Okay, number 5 and number 6. Notice how number 5 and number 6 are different. So how are they different from our previous problems? So notice how in our previous problems, we had just a monomial times a polynomial. And in 3 and 4, we had some subtraction going on between two monomials times a polynomial. What we have on 5 and 6 is that we have a polynomial. This is a polynomial, and it's being multiplied times a polynomial. So this one's going to be a little more tricky. We have two terms inside that first parenthesis. Each one of those terms inside the first parenthesis must distribute into the second parenthesis. And so we are still doing the same steps as far as distributing. However, now we have to distribute both terms into the second parenthesis. So the only difference now is because we have more than one term in the parenthesis, we must distribute both of them. So our first step we're going to say is to distribute. And remember, distribute means multiply. Put that in there, multiply. Each term in the first parenthesis to each term in the second parenthesis. So I'm going to show you a couple ways that you can do that. It depends on what type of learner you are and whether or not a visual makes it easier for you. And then you get to choose which method you prefer, because either method will work as long as you do it correctly. So let's look at each term in the first parenthesis. My first term is this x. So I need to make sure that this term x gets multiplied by each term in the second parenthesis. So I'm going to do x times x. And then we take that same x and we're going to multiply it times the 3. Now, I want to take my second term that's in the first parenthesis and multiply it by each term in the second parenthesis. So this is 4 times x, and then 4 times 3. So our next steps are still the same. The second step then was to use the rules to do the multiplication with exponents. So the x times x becomes x squared. The x times the 3, we're going to write that as, since it's positive, that's a plus 3x. 4 times the x is a positive 4x. And then 4 times 3 is a positive 12. Last one is still combine like terms. The nice thing about these problems is that your like terms end up in the middle. So we end up with x squared, and then plus 3 plus 4 is a 7x, and then last plus 12. So our answer is x squared plus 7x plus 12. Now I said I was going to show you a different method. So if the way that we did it with the arrows on number 5 was a little confusing, on number 6 I'm going to show you the same method as before plus another one, and then you get to decide which one you like better. So let's start with distributing what we have in the first parenthesis to everything in the second parenthesis. So we get a 3x times a 2x, and then 3x times a negative 5. Remember to take the sign with the number. Now we take our second number that's in parentheses, and this time notice it is a negative 1. So we're going to do a negative 1 times 2x, and then a negative 1 times a negative 5. When we multiply and use our rules, we'll do the 3 times the 2, and then x times x. That gives us 6x squared. Using our rules, we get 3 times a negative 5 and then the x. So 3 times a negative 5, that's a negative 15. So we'll put a minus 15x. Using our rules, our numbers are already together. Negative 1 times 2 gives us a negative 2, and then the x comes after. And then last, negative 1 times the negative 5, we multiply that out. That's a positive 5. When we combine like terms, our two middle terms are like. If you like to, write them up and down. So 15x minus 2x, that's going to give us a negative 17x. So my final answer will be 6x squared minus 17x plus 5. Okay, the second method is known as the box method. It's just a visual to do the exact same process. The box method says I'm going to create a box. And what I'm going to do, on the top of the box, I'm going to put however many terms I have in the first parentheses. So I got a 3x and then a minus 1. And I want to separate those. So it's how many columns I have. The number of rows come from the second parenthesis. We have a 2x and a negative 5. So I put a line between those. And now we are going to fill in the box by doing your multiplication table. So to fill in the box, we take the number on top, the 3x, we're going to multiply it by the number on the side, the 2x, and that will give us 6x squared. Again, fill in the box, we got a negative 1 times a 2x, that gives us a negative 2x. To the bottom left, we take the 3x on top, multiply it times a negative 5. This gives us a negative 15x. And then last box, we have a negative 1 times a negative 5, and this gives us a positive 5. So now we have our answers in the box. We need to take them out of the box. So the numbers you came up with, we have the 6x squared minus 2x minus 15x, and then plus 5. Again, notice this is the same thing we had on the left-hand side when we distributed. It's just another way of visualizing how to do the multiplication by using multiplication table. Now we can combine our like terms, and we end up with 6x squared minus 17x plus 5. So again, the choice is yours, which method you prefer, using the arrows or the box method. And now we will apply that to number 7. We're going to find the area of the rectangle below. So to find the area, we do length times width. And this is giving us that the length is one side, the width is the other side. So to find our area, it's going to be 4x plus 3 times 5x minus 2. This is a time for you to choose the method. Do you want to set up the box, or do you want to use your arrows? I would suggest pausing the video, attempting it, and then starting the video and see if you get the correct answer. So we're going to take the first term as the 4x, multiply everything in the first parenthesis, 4x, by everything in the second parenthesis. So times 5x, and then we have 4x times the negative 2. Now we take the other term, the 3, positive 3, so this would be a positive 3 times 5x, and then positive 3 times the negative 2. Let's multiply out. We have 4 times 5 times x, so this is 20x squared. We have a positive 4 times a negative 2 times x. This would be a negative 8x. Positive 3 times a positive 5x gives us a positive 15x. And then 3 times a negative 2 is a negative 6. Combine the terms in the middle. We have 20x squared. Negative 8x plus a positive 15 gives us a positive 7x and a minus 6. So to summarize, how can we multiply polynomials? We have two different kinds. We have a monomial times a polynomial. So if it's a monomial times a polynomial, then what we did was we distributed the term on the outside of the parentheses to every term on the inside. So to every term on the inside of the parentheses. That means we multiplied them. Second, we use the rules of exponents to simplify. And last, we combine like terms. When we had a polynomial times a polynomial, first, the rules are the same other than the first one. So the first step, the only difference is that our first step is that we use each. That should be each. Each term in the first parenthesis and multiply it by each term in the second parenthesis. Let's multiply each term in the second parenthesis. Everything else stays the same. This concludes topic 14-1.